So, guys, can we can start now? Can we start?
Yes, sir.
Yes, sir.
So, guys, we will be starting as usual. The same question. Anything that is covered in the last lecture is not clear to you guys. So today, what's supposed to start? You wanted that the code that shared with you before practice that should be covered, or theory. I should be starting with theory first, guys.
सर कल जो शेयर किया था आपने उसमें थोड़ा उसको एक बार और डिस्कस कर लेते थे।
Confusion है?
Yes, sir.
Okay. So I shared that is okay. So let me just open this. So I think this that I have shared with you people. So it's visible now, guys. Guys, my screen is visible.
No, sir.
Sir, I can't see.
In fact, I have not shared, just I shared it.
Yes, sir. It is visible.
Visible, okay. My voice quality, everything is okay.
Yes, sir.
Okay. So exactly where you people facing a problem? One approach would be like I will be the point where I left it out. From there onwards, I should start, or you wanted a selective that queries to be addressed. So guys, please let me know. Guys, I'm
Sure.
waiting for your response.
सर मोड से
So you wanted to be start with mode, right?
From where you left. Yes.
Okay. So you wanted, so this median was covered, right? Mean median mode
Yes,
was
sir.
covered or not?
no sir actually not covered.
Actually, we started, we
आप
finished
sir
up to
need to
this,
start.
right?
So,
Yes, sir.
So what we can do, we can explore this point onwards. So
Okay.
just a minute, guys, just a minute. Yes, Gaurav. तो बता देते ना यार. Okay. So guys, you wanted, so let me run the cell above those. So this cell is selected. So I will be running all the cell above this. So I'm running all the cell above this. What happened? It has run all the cell. I have selected something wrong, guys. Hello?
You have provided us a PDF file, so we can't run.
No, but you might have seen this. So let me this cell, run all above. Now I will run this. Now I think I'm running this only, okay? So guys, come to this measure of central tendency. So here measure of central tendency, all we know there are three tendencies are there. Generally we talked about mean, median, mode. And in fact, we have discussed in detail when we were covering the theory that how you can calculate the mean, why we are using the mean, and there is a drawback in the mean. We discussed in detail. After that, we started discussion on median, and again on median, we discussed in detail how to calculate all those things. And then we started discussing mode, and in mode discussion, we very much clarified that mean and median is for numbers, and most of the time we will be using for categorical variable. But at the same time, if you want, you can use it for numerical data as well. But most of the cases you will feel there is no logical sense to using mode for category numerical variable.
Hello.
Hello, guys.
You are audible, sir.
Yeah, in fact, I kept myself on mute.
Yes.
Okay, so now thing is working fine as expected, right? So now come to this, guys. So mean all we know, median all we know, mode all we know. So now this is the formula, everyone knows this. So here basically what we are doing over here, we are counting the, so in fact this is in with the reference of this experiment. If you recall, we were doing one experiment yesterday, we have discussed it, we were doing that, we are tossing a 5 coins simultaneously, right? 5 coins simultaneously. This was our experiment, guys.
Yes,
Yes,
sir.
sir.
And we are doing this experiment 1000 times, right? And we
Yes.
have provided, by saying 0.5 probability, we are saying to the system the coins are fair coin, right? So expected result basically we are expecting, obviously it will be a 2.5 only. If we talk about head, there is a 50% chance that head will come, 50% chance that tail will come. So on an average, our expectation is 2.5, right?
Yes.
Yes.
Okay. So now, and at the same time, all we know this is random process. So exact 2.5 getting a mean, almost not possible. Maybe if take n tends to infinity, that time it might possible, but sometime but most of the cases you might feel some value maybe more than this, some little bit value less than this, but nearby 2.5 will be there if you take n is very large. So see over here, guys. So this is a head count is what? Head count is a numpy array where basically you are going to have on a particular trial how many times you got the head, right? So for example, last 20, this is the last one. This is a 1001 trial where when you did this experiment, you got 2 times head. Before that, 999 times on this term, you got head only once, right? So this is clear now, guys, to all of you. This
These
head
are
count.
starting first, no? Starting 20, no? We are
This is
doing
starting
slicing.
20. Sorry. This is starting 20. Sorry. This is starting 20. This is start, then end, right? And
Yes,
step is
sir.
going to be a, by default, if it is not provided, it is going to be a +1, right? Clear?
Yes, yes, sir.
So you can see over here, when we done the average of those values, so we are summing of all those values, how many times head has came divided by total length. So this is 2.47. So we are okay with this because we were expecting 2.5, now it's 2.47. So almost we are on the same page, right? Clear? In fact, this is by coding basically we are doing. Same thing we can achieve by using numpy mean function, np.mean, because this head count is a numpy array, so we can use np.mean and we are passing the numpy array name. And again, from this library also we are getting 2.547, right? Clear?
Yeah.
Okay, so this is proving that this expectation formula that we have derived is correct, right? Clear?
Yes.
Yes, sir.
Okay, so now come to this. So this is okay. Now let me just take you further. Now, guys, in case of median, how we calculate the median, guys? The first step, I think if you can collect correctly, the first step was just sorting the numbers, whatever numbers given to us, maybe ascending order, descending order. Then we have to select the central value, that will be the median value, right?
Yes.
Okay,
Yes, sir.
but again in central value there are two possibility. If number of numbers are even there, then in this case there are two central values. If numbers are odd, then there will be one central value, right?
Yes.
So in this case, 1000 is an even number. So there will be a two central value. Which location? 4.99 and 500. So if you basically just go and indexing, the value is stored at this location, you came to know this is 3, this is also 3. So obviously the median will be a 3 only, right? Clear?
Yes, sir.
And in the
Yes.
same way, you can basically that use the NumPy library np.median, and this is also coming to be equivalent like this only, right? Now you might be confused over here. Here basically I have not used NumPy library. In fact, I have doubt that NumPy having a mode functionality. Guys, anyone has checked it? NumPy having a mode functionality? Guys, guys, let me just check over here. Guys, can anyone check NumPy having a that mean mode facility or not? Guys, are you there?
Yes.
So np.mode, let me check, is there or not? So this is again, I think NumPy doesn't have, right? Clear?
Yes, sir.
Again, they are using stat library. Okay?
Bye.
Yes, sir.
So they are using this stats module. Okay. So now let me just take you people on the same notebook. So that's why basically we have used ST, and ST is basically what? SciPy states module is there. So from state, basically this is the alias ST. Now we are calculating the mode. So guys, when you run this program, it will give some sort of basically tuple type structure. It is not a tuple, but it's tuple type structure. You think in this way, okay? In fact, we can check it. What is the type of this? This is not exactly tuple type, but it looks like a tuple looking this, but this is not a tuple, I can tell you. So let me just check the type of this. So let me just copy this head count here only. In fact, I have to check the whole. So let me copy over here. So guys, can you see over here? This is some sort of basically that you can think of tuple or array type, basically exactly not, neither is tuple not array type, but indexing will be same. So here two elements are there. So in order to basically grab this first element, what you have to do, guys, basically you have to use this 0 first index. So when basically you are going to use the first 0, then it will basically going to retrieve this thing to us. Let me just show you. We will reach over here. Now we have to grab this first element inside the array. This is not a simple element. This is a element stored inside the array. So if we want to grab this 3 exactly, then you have to use one more indexing level. Right, guys? Up to this point, we are okay?
Yes.
Yes, sir.
Okay. So, guys, this is very important. Just recall when we were discussing the mean, we discussed that time there is a there is basically that some drawback in the mean, and drawback is what? Very sensitive towards outlier. Okay. So obviously if we are working a very small population, let's say 2-3 numbers, so there is no sense of outlier in 2-3 points. What will be the outlier? So obviously in that case we will be always preferring mean. So that's why they have written it for small sizes. Mean is typically provided the most accurate measures of central tendency, right, guys? And when the numbers are very large in numbers, that time generally we should avoid this mean calculation. We should go for the median if we wanted to represent a single point summary for the population, guys. So am I clear, guys, with this?
Yes, sir.
Okay. Now, guys, in fact, recall the time when I was covering basically that the context was when I started comparing two numbers that having a same mean. Doesn't it doesn't mean that both numbers are same. No. Then we started a discussion about that mean is same, variance is same. Is still any comment on their equivalency? Then we decided no, this is also not sufficient. Then we go for the shape. So shape basically is nothing but basically frequency count or distribution. So here basically now onwards basically we are talking about the skewness. It's shape, right, guys? Okay. So guys, if you recall, there are two skewness I discussed with you. One is right skewness. Right skewness basically the tail is extended towards right. Okay, tail is extended towards right, and left skewness basically is what? When your tail is extended towards the left. Okay, guys, idea is clear?
Yes.
Yes, sir.
Yes, sir.
So guys, here basically just we are using this only. We wanted to generate 1000 point from a particular distribution, and here basically this zero basically is specifying this whatever data basically we are selecting, that is coming from the normal distribution, symmetric distribution type structure, right? Clear, guys? Guys, hello.
Yes, sir.
Yes, sir.
So idea here is this: if it is zero, that means balanced. There is no skewness. If it is positive, that means right skew, right? More is the value, more is the skewness. And if it is negative, then it's going to be a left skew, right, guys?
Yes, sir.
So
Yes,
with
sir.
this, when we execute this, let me start the execution. Then it will be much more better for us basically in fact, I will be executing also. So let me reach over here. I will be executing over this also. So let execute it. So by execution of this, we are going to get the 1000 element that going to store inside the X variable, right, guys? Now we are going to create a blank canvas by this command. At the same time, basically, we are fixing a plot over there, blank plot, right, guys? Clear?
Clear.
Yes.
Okay, and apart from this, guys, basically see over here. What we are trying to do over here, basically we are trying to draw two vertical lines, AX vertical line. Here basically we are passing the value. So basically we are saying, if you recall the coordinate geometry, x is equal to 3. A line will be parallel to y axis. This will be x is equal to 3, guys. This is
Yes.
going to infinity, right?
Yes.
Right.
Okay, so the same thing we are trying to draw with the help of matplotlib, because PLT is calling all those things. And now basically we are saying for this mean representation, we are going to use a line that of color orange, and we are going to use a line of color green for median representation. And we already discussed, in case of symmetric distribution, mean will be equal to the mode, is equal to the median, guys. That we have discussed, guys, if you recall.
Yes, sir.
Okay, so that's why when you basically overlap these two lines, this green basically, I don't know that artist can tell to us which basically that orange and green both are overlapping, but it still looks like that green is visible, right? Clear?
Clear. Yes, sir.
And the third line basically is specifying the color, histogram color. Okay, and guys, this is the Python syntax. I think you people might be knowing. If some function returning something and you don't want to utilize that, you don't want to use that value, then in this case you use dash, right? Clear,
Yes,
guys?
sir.
Okay, otherwise what will happen, if you recall, if we are using this only, this executing this only, this plot will get will display to us. Apart from this, there is some textual things will also get displayed over here, and that sometimes create as some sort of annoying thing when we try to look the graph. Okay, guys, so can we move ahead now?
Sir, which
Yes,
kind
sir.
of text it will be print?
What you are saying, pardon?
Which kind of text it will show if we
This
don't
is
use
this
a
is
dash?
basically, this is in fact discussed so many times. See over here, this
Okay.
discussed so many times, right? PLT dot show, if we show, then it will not be displayed. Okay,
Yes.
clear?
Clear, sir.
Yes, sir.
Now this will be a right skew. Okay,
Yes, sir.
so right skew basically means what? If you see over here, that mean, in fact we will take the median also. Let me just copy this and let me just copy over here. Now you will be seeing two line. What happened? Sorry. This yet to execute it, right? First we have to execute this, then we can execute this. We will see two lines. Now it's clear, guys?
Yes.
Yes, sir.
Recall when we were discussing that symmetric asymmetric distribution, that time I conveyed you intuition based proof also I have discussed over there. Why mean, median, mode are equal, or why not they are equal. If they are not equal, how there will be a relationship among themselves. So that all those things are discussed over there, right?
Yes.
Now, so same thing basically this also. In fact, sorry, basically I should have not done this. This is there already there, same thing. Okay, so let me just pass on all those things. So guys, we have discussed mean, median, mode. Now this is quantiles. So quantile, I think we have discussed in depth also. Quantile basically we discussed when we discussed the box and Whisker plot, right? So this is
Yes, sir.
going. So this is Q1, this is Q2, and this is Q3, and I have drawn with the intention this is symmetric distribution, right? This is a perfectly look like a symmetric distribution. Okay, if it is asymmetric distribution, in this case either it will be a left skew or right skew. If this Q2, let's say, shifted over here, somewhere over here Q2, then in this case this area will be much higher side, that means right skew, right? Clear?
Yes, sir.
And if Q2 somewhere over here, then it will be a left skew. So this is one way of checking whether distribution that we are studying is symmetric or not. This is one check. Another check basically, this is given in some of the books, not in all the books. You will find this length and this length also play a role over here. If these two are similar, if these two are same length, that means these two are similar, and Q2 minus Q1 is equal to Q3 minus Q2. Two cases. This Whisker length should be also similar, right? Both should be same. Then only we will say this is a symmetric distribution. Otherwise, we can't say symmetric distribution, right, guys? Are you clear?
Yes.
Okay.
Yes, sir.
So now let me just take you to quantiles. So guys, by the way, median is also Q2. Can we say center point?
Yes, sir, we can say that.
Okay, so this median through numpy function np dot median, we are passing x, which x that we have created recently, this x created recently, this is right skew 1000 points we have generated over here, right guys?
Yes.
Okay, now come over here. So guys, quantile, in fact guys, there one more function we will see, percentile function also there. So in numpy, percentile is there, quantile is there, both functionality is same. Only difference is the way basically you are passing the parameter. Let's say if you want to calculate the median, in this case you will pass the value in fraction, right? You will pass the value in fraction over here. So 50% basically 0.5 written over here. So let me execute this. In fact, if I execute this, you are going to see both values look coming same, right guys? So this idea is clear why they are coming same.
Yes, sir.
Okay.
Sir, can you repeat, miss, what is that fraction? I'm not getting.
This 0.5.
Yes, sir.
This ideally mean basically means 50%.
Yes, sir.
So this 50% in case of quantile will pass like a 0.5. Okay.
Okay, sir. Got.
Now this percentile method and this quantile both giving the same thing. Only thing is if you are using percentile and you want it to 50 percentile, so then again you have to use np dot percentile rather than using 0.5. You will use direct value, right? Okay.
Yes, sir.
So let me just show you. Percentile significance is, I think, clear to all of you. Percentile basically means if we are calculating 95 percentile of this population, means that means there will be a whatever value going to return by against 95 percentile. So almost in the population, 95% of the value will be lower or equal to that value, or there will be a 5% chunk of the value will be higher or equal to this value, right? Clear, guys?
Yes, sir.
Yes, sir.
So see over here, this is now. Let me just draw all those things. If we draw basically, this is P0 basically means 95 percentile. Okay. P1 basically means 99 percentile. So can you see over here, guys? These two lines basically we have drawn over here. This yellow color corresponding to what? Maybe yellow or orange. We should say orange. Orange basically is corresponding to 95 percentile, and red is corresponding to 99 percentile. Right, guys? So I think both are clear, guys. Idea is clear.
Yes, sir.
Yes, sir.
Okay. Now come to this. Now guys, see over here, quantile. If we are using quantile, we are using, instead of 95 percentile, we are using 9.95. And when we were using this percentile, that time we were using, let me just make this.
95.
Okay,
Numbers we are using.
so please take care of this. Okay, as such, there is no difference. Logically, both are working in same logic, but the way basically they have designed, the way basically you're supposed to pass the parameter or argument is differing by this phenomena, right? So one is passing directly probability, one is passing percentage. Okay, clear guys? And
Yes,
this
sir.
is what
Yes, sir.
this is what we are basically now going to discuss the box and whisker plot. So we started calculating the percentile. So 25 percentile basically we are calculating the Q1. This is a Q1, right? This
Yes,
will
sir.
be Q2. This will be Q3. Okay, guys. So some sort of this whisker plot basically we are creating here. So let's say this is the middle point. So this is Q2. This is Q1. This is Q3, and this is whisker, right?
Yes, sir.
And if you recall, I told you how basically you have got this point, so that you have drawn this vertical line. Why basically you are drawing over here? Why not over here? Why not over here? So I have given the formula. At the minimum side, you have to use max of two values. Which one is maximum? That basically will be deciding factor for drawing this vertical whisker, right, line. So here basically either you will take one value is minimum of all the points present in this data set, and second basically you will have q1 minus, because it's less than the q1 minus 1.5 into iqr. Can you recall guys this?
Yes.
Yes, sir.
Sir.
Okay, now in the same way here basically will be a minimum opposite. So in this case it will be what? Minimum max of x minus, sorry, q3 this side, q3 plus 1.5 iqr guys. So all those stuff basically we are going to do over here, right? Clear? So we are going to
Yes, sir.
do this thing over here. So let me just take you. So guys, see over here what I am trying to do over here. Just a minute, just a minute. So we have calculated this. We have shown graphically this also. Same thing. So guys, this syntax I think will be clear. Repeatedly we are using the same syntax, right? This light gray for histogram, different color for different. This is Q1, this is Q2, this is Q3. So am I clear, guys? Everything is clear?
Yes.
Yes, sir.
Yes, sir.
Okay. So now let me just see this decile. Decile, you mean, understand the meaning? Decile means here it is going to divide our data set into 10 parts, right? Guys,
Yes.
Yes.
so
Yes,
here
sir.
basically we are passing basically percentile as a numpy array over here, and we will pass over here, and this basically be creating a, right? Clear,
Right.
guys?
Yes, sir.
Clear.
Okay. Now let me execute this also. It's clear. Now please pay attention. Box and whisker plot. Box and whisker plot is very useful in data science. It is a plot that is mostly exploit the time when you wanted to have some study on outlier, right? So please pay attention over here. So guys, when you plot this box plot, you see over here there's a lot of points on the right hand side of this whisker, right guys? So these all are outliers. Okay guys, and,
Yes,
and
sir.
these are outlier because their value basically q3 plus 1.5 iqr value is lesser than these points. Lesser, this point, this value basically will represent the this value, right guys? And all those values basically are higher side. That's why we are saying this outlier. But again guys, this is subjective call. Why 1.5? People sometimes used to say n into iqr. Let it be generalized, right guys? So subjectivity of outliers depend person to person. It might get changed. Okay guys?
Okay,
Yes.
sir.
Okay. Now guys, let me just take you Yes. So this Q basically we have already calculated. This Q basically means what? This is Q1, Q2, Q3. Okay, guys. So what is
Yes,
IQR,
sir.
guys? What is IQR formula? IQR formula. What is IQR formula?
Q3 minus Q1.
Q3 minus Q1, right?
Right.
So this is Q3 minus Q1. So this is going to be a this minus this. So you can see over here 1.194 they have taken, 0.325 they have taken. So this is IQR value. Now again we will working upon this model. Max, if it's there, then we will say minimum of, sorry, if it is a max, this side max, okay. Then there will be minimum of all the points minimum value, and it get compared with Q1 minus 1.5 into IQR. So that stuff basically we are going to see now. So let me just sit and convey you. So guys, can you see over here? Guys,
Yes, sir.
so this is basically we are doing this stuff. We are doing this stuff, this one. This stuff basically for Q1, this we are doing, right? Sorry, minimum basically is this. Okay, guys?
Yes.
Clear? I think some
Yes,
mistake I
sir.
have done it over here. You have to correct it. This is basically again a Q1 minus basically we have to check it, right? Please, I will also correct it. Please correct it over here. Okay, guys?
Yes, sir.
Yes, sir.
Because this the mathematical formula is this that we have to basically work upon. Now, let me basically just take this. Let me just take further. So guys, this is all you can do it. Apart from this, guys, now see over here. Now we have taken a one data set. Till now, basically we were working upon cooked up example. Now actual data set we have taken. This is iris data set. So guys, all of you are familiar with iris data set, guys? Guys,
I have heard, sir.
you heard.
Yes, sir.
So let me just take you on iris data set. So let me just show you what does mean by this, all those Satoja versicolor. So all those basically I'm going to explain to you. Iris data set. What I mean, beta?
It is related to flower,
Yes,
iris.
Sir, I think it is called Hello World of Machine Learning, right?
yes. Iris or Titanic data set.
Yes.
Okay. I wanted to show you something. There is one figure is there. Hmm. Rather than going this, I should go with this Wikipedia. Iris dataset, sorry. See over here. I wanted to show you this. Okay. This is basically Iris dataset. Okay, so this is there. Okay, so here basically what they have done it. Let me take you on the spot. So guys, can you see these four features? So guys, when you see the flower over here, so basically you will see over here. In fact, I am not finding that one figure. Basically, see, there is basically one length over here. Okay, one width over here, right? Clear?
Yes, sir.
Yes.
So basically, I don't know. Basically, it's a petal or sepal. So one is petal length. Let's say this petal width. Okay. Then here basically something like that. Basically, sepal length, sepal width, something like that. Okay. The one figure is there. So anyhow, I am not a domain expert of this. Okay. But idea here is this. They will give four features to you. Randomly, they will pick one flower. Randomly, they pick one flower, and there is an automatic machine. You can think in this way. This automatic machine basically will scan this flower, or maybe manually one expert will tell you the value of all those four parameters. Sepal length is how much, sepal width is how much, petal length is how much, petal width is how much. So all those four values are going to get it. So these four values basically this flowers get it transformed over here. So based upon what is going to given to you, I am saying query point. These four things, SL, SW, petal length, PW, this four thing will be given to you. Now based upon this, basically you have to tell whether this guy, the new flower basically that is given to us, to verify whether it's a Satoja, whether it's a versicolor or Virginica, right?
Right, sir.
So this is given to us, okay? So now let me take you this over here. Just a minute, let me delete over here. So guys, this is given to us, okay? Now idea here it is, we are going to draw the box plot for the whole data set. We are passing the whole data set. So there are four numerical columns are there. This box and whisker plot is giving meaningful things when basically you are playing with the numerical data, right guys? Clear? So guys, this sepal length, sepal width, petal width, corresponding to that basically you can see a box and whisker plot over here, guys. So guys, do you see anywhere basically any outlier is there or not? Guys,
In sepal width, there can be seen that there are outliers.
yes. There is some outlier this side as well. There is some outlier this side as well, right? Now everywhere, apart from this, there is no outlier. Okay, guys? Clear? Clear, guys?
Yes, sir.
Yes. Yes,
Okay.
sir.
Now, guys, see over here. See, guys, one more thing I want to tell you. This C1 library having nearly 10 to 20 data set. I don't know the exact count. So those data set is given for our practices purpose. So you can find not only this Irish data set, you can find some other data set. So there is one tips data set is given to us. So this is tips basically something that if we go for a dinner or lunch on a restaurant, so that we used to give some tips, all those things. So this tip related data is given to us, they have collected, and this is given as a part of that data set of the C1, so that as and when we require we can practice the C1 syntax, C1 basically library, right guys? Idea is clear?
Right, sir.
Okay,
Yes, sir.
so now you tell how many box and whisker plot will be displayed if you see this. Yesterday we have discussed in detail. How many whisker plot basically you can think of?
The number of numerical columns.
Number of days. This column, right?
Yeah.
How many categories are there? This is basically days, not a numerical column. Here day basically is count. It is spelling count 1, 2, 3. Not more than that, right?
So to no or yes. Sorry. 7. Saturday to Sunday.
I think that is also not there. Let me check.
Number of I think days in a week.
Tips dot day dot unique, right?
Yes.
How many there? 4 are there, right?
Okay. Okay.
So that's why you are going to see a 4, right? And this double why you are saying basically because here hue basically is partitioning further, and partitioning with the group. How many groups are there? Depending upon how many categories are there, and for each group there will be a different color coding scheme, right, guys?
Yes, sir.
Yes, sir.
Yes. Sir.
Okay, so this is clear. Now come to this measures of dispersion. So measure of dispersion basically in that basically we have discussed about variance, standard deviation. Then in fact, if you recall, we also discussed about range. We also discussed about MED, right? Okay, guys. MED
Yes, sir.
basically means what? Mean absolute deviation. Okay. So what I am looking for once you finish this, just come up two more dispersion parameter. One is basically mean absolute deviation, right? And another is what? Range. Okay, guys. So here basically, let's talk about variance. Okay, so variance formula is what? I is equal to n summation n. I have not used this n minus 1 because most of the time in machine learning this n and n minus 1 both are almost same. There is no difference sometimes, right? Because data set size is too much. Okay, so divided by 1 lakh divided by 99,900, again same thing, guys. Okay, clear?
Yes, sir.
Yes, sir.
So I have not done this. So guys, all of you know how to calculate this. So one way basically is what? First you calculate the mean. We have calculated the mean by using NumPy facility, right? So we have calculated the mean of all the population that is represented by X. Now basically what our objective basically is to calculate the sum, each sum square, right? Each basically the point distance from the mean. So this is in squares. Why in square? Because if you take on the without square, then one value might cancel out other value. So that we don't want, right? Clear, guys? Guys.
Yes, sir.
Yes, sir.
So see over here, and then we used to say summation I is equal to 1 to n, and we used to divide by n, right? Okay, guys. So we are doing this thing. We are doing this thing, guys. Can you see over here, guys? Guys, this is clear.
Yes,
Here basically we are basically saying the first element how far from this mean, second element how far from this, third element how far from this. All those things basically have written over here, right? Now we are basically going to sum up all those things and divide by the number of elements, right, guys? We are basically going to sum up all the difference. Can you see over here, guys? Guys,
Yes.
Yes, sir.
divided by length. So now we got this value, and almost same value basically we got from NumPy hidden basically functionality, right? Clear,
Yes,
guys?
sir.
In the same way, basically, if you want to have the standard deviation, so we discussed already. Standard deviation is nothing but basically square root of variance, guys. So you can calculate the standard deviation by this formula, right, guys? Okay.
Right.
So in
Yes, sir.
NumPy, the takeoff is that mode function is not available. Okay. And then basically we are drawing the graph over here. Okay. Okay, guys.
Yes, sir.
Yes, sir.
So guys, now what I will do over here, I am giving 10 minutes break. Meantime, basically, I will be basically going to fill my water bottle. Then I will come back. This is not a break for something. This is break for practice. Whatever PDF I supplied yesterday, just you have to code over here right now. Okay?
Okay.
Clear?
Sir.
And
Yes.
once anyone confirm this, sir, we have to move. Then we will start a new theory, right? Okay.
Right, sir.
So this way of teaching is correct now. First, we are covering the basic fundamental concept behind the scene. Whatever basics are there corresponding to a particular topic, we are covering that. Then we are trying to come up with some codes also, right? Clear?
Yes,
Yes,
sir.
sir.
Yes,
Okay.
sir.
Okay, guys. Okay.
Excuse me, sir.
Yes. Yes. Yes.
Hello.
Bolo.
Sir, is it always necessary to remove the outliers from the data set?
See, you know what is outlier? I will give a very layman intuitive example. Let's say uh, uh, in your batch, let's say all are good students, right? Okay, all are good friend of each other. See this scenario, right? And there might be one or two students, as an individual, whatever you do for them, they will not appreciate you all the time, right? Clear? Okay, now as a survey agency, I came and start interacting with your batch, and suddenly, you know that I got a chance to meet those 2 3 guys. Which 2 3 guys? They never basically ready to appreciate some other person. So when I have an interaction with them after finishing the interaction, if you ask me that what you think of what type of class is this, I will be carrying a negative impression. Am I right?
Right.
So those 2 3 people only, but you are in majority 60. So these 2 3 basically some sort of are very different from the population. They are the outlier. right? So sometimes those outlier might basically disturb your prediction, your model, right? Your interpretation, your pattern finding. The moment I was discussing with them, I was trying to find some pattern, what exactly the behavior of the class will be, and accordingly I supposed to report. I will be reporting a negative thing because I am inspired with the outlier, right?
Yes.
Clear?
Yes, sir.
Idea is clear. So before, you know, so outline may be like this. For example, let's say you are collecting data related to age. So by mistake that you wanted to type 80, but suddenly somehow it got replaced with 800. Let's say. Okay. So what you will do? If there are 10,000 points in the data set, so one point will not disturb you. One row you can delete without thinking of anything, right? So this is one way of easiest way of dealing outlier. Second basically is what? If there are so many values like this, let's say there are thousands row and there are 10% rows like that only. So out of 1,000, if you start deleting those 100 rows, that means you are going to lose a lot of information, right?
Yes.
So in this case, what you will do, you will basically going to be in a compromised state. But you will say, just for a moment temporarily we are not considering outlier, so there is a 90. So among 90, what is the maximum value? Let's say this comes out to be, out of 90 people, let's say comes out to be 75. So what you will do, one way of replacement, maybe what you can do, you can say basically that replace all those outlier value of higher side, let's be 75, right?
Hmm.
Or maybe you can take the mean of 90 people, just discard outlier, take mean of 90 people, and then come back and the substitute mean against those 10 outliers, right?
So we have to replace outliers with the mean.
Yes, no. I'm giving my example. Mean,
Okay.
maybe sometime basically, let's say there is a one disease, sarcoidosis, or maybe that asthmatic what is one parameter is there. I'm just recalling one parameter. So, guys, anyone having any idea regarding asthmatic? There is one term over there. In fact, let's say take a blood pressure. So generally we know, as an Indian, we know the 80 to 180, 180 to 120 is the ideal range for the blood pressure, right?
Yes, sir.
Yes.
Clear? So now, and consider one scenario. You have no idea 80 to 120 basically is the ideal range. But
Hmm.
when you are analyzing as a basically dumb data scientist, just you are playing with that data only, you have no idea about the word. So what you will, and you suddenly you got a value of let's say 2000, you will stuck. Most of the value in the range of this sensible range, this is outlier. So
Yes.
by which value I should replace this? So the ideal way is what basically you will go to the doctor. Doctor means domain expertise. You will go to the doctor and you will say, sir, for this BP, that parameter, I don't know what is this. This value is not looking in a sensible range. What to do? So that guide by say, oh, if this is missing, then in normal cases, by considering other parameter, this person looks like a healthy person. So this will be the value. Okay.
Okay.
So it's a subjective call. ओके
Yes, sir. Clear.
क्लियर ठीक है हम लोग 10 मिनट का ब्रेक देके हम वो मिलते हैं ठीक है Hello guys, can you hear me now?
Yes, sir.
My voice is audible? Perfect.
Yes, sir.
Okay. So we are good to go, or you required 5 to 10 minutes more time?
Required time, sir.
Sir, please, cell number 15 explain कीजिए.
Serial number?
15.
Box and whisker plot.
Sir,
Serial number 15 is box and whisker plot, right?
in लिखा है ना sir, what 15.
In 15, okay, 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 okay. So let me take in 15. In fact, you are talking about your PDF now?
Yes sir, in video.
So let me, in fact, what I will do, I have to, because I ran those cells in different order, right? So let me just restart and run all. Then we will go to line 15. In 15, just a minute.
The box.
Just wait a minute. Now every line got executed. So let me take the things on in 15. Sorry, in 21. So we reached over here in 15. Yes. What is the issue?
50 sir, 50.
550. Okay, 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 okay. 50, 50. Yes, 50. What is the issue? Beta, what is your query? Hello? See, guys, my voice is audible?
Yes.
Yes,
So,
sir.
so see
Yes,
over
sir.
here. If you are clear with 47, then you should be clear with 50. 50, what we have done it, we are saying np dot percentile. And here basically we are first argument x, we are randomly generated a big array of 1000 values. And then we are saying, please give me the 25th percentile, 50 percentile and 75th percentile. Essentially we are saying, please give me this. This is the Q1, this is Q2 and this is Q3. Am I clear? Right? Now, instead of this, there basically what we have done it, basically we have used the range. Again, range is also responsible for creating a list now,
Yes,
right?
sir.
Starting with 10 and saying go up to 100, and we are saying just basically use 10, or maybe I think starting with 0. Let me check what is we have used it parameter. Starting with 10. Okay, clear? So what is the issue now here? This range internally will create this type of structure. Am, am I clear? Guys,
Yes, sir, next cell. Explain.
next cell,
51 one.
51, okay.
Why we are using for D dash I?
This is first of all, this is a list comprehension, right? Are you getting? This is list comprehension. So basically what we are doing over here, basically for every value of D, okay? Within D, these are the values. These are the values, right?
Yes sir.
So at a time we are taking one value. Let's say first time basically we have taken this value, and then this value feed it over here, and ultimately it will goes over here. This is responsible for generating this line, first line number 1. Right? Then this value is responsible for generating line number 2. This is something that let's say this is A. Suppose this is
Sir,
A.
your voice is breaking, sir.
My voice is breaking for you only or for everyone, guys?
Yes, sir. Break.
It is low, sir.
Breaking. Now, guys, now it's breaking.
Yes, sir. Clear, sir.
Now clear, sir.
Clear. I think some issue in my laptop. I think I have to check it, or maybe I have to use another device for all those stuff. Okay. So, guys, this is clear now. So this is something like that. Let's say this is A. So corresponding to A, we are getting the first line. Corresponding to B, we are getting second line. In the same way, let's say this is the last one. Let's say this is, let's say C. So this is corresponding to this C, and this is something like that. Basically, we are saying X equal to C. So X equal to 3 when we, or maybe X equal to C. If you know the high school 10th that coordinate geometry. So this is going to be a vertical line parallel to y-axis. This is going to be x equal to c, and this is going to touch an infinite space, right? Am I clear?
Yes, sir. Now clear, sir.
Okay. Any other issue, guys? So we should wait for 5 minutes, or we should go?
Wait for 5 minutes.
Okay, you take 10 minutes, yeah. No need to worry at all, okay? So, 10, 14, 10, 25 exactly I will be starting, right?
Yes.
Yes, sir.
Right, sir.
Okay. And please, जहां भी कहीं परेशानी हो, प्लीज लेट मी नो, ओके? मैं आपको प्रॉपर बताऊंगा. बस मेरे को एक चीज में इरिटेशन होता है, दैट इज प्लीज बी केयरफुल अबाउट दिस. वंस यू विल कंफर्म सर ये कॉन्सेप्ट क्लियर है, उसके बाद अगर मैं पूछता हूं तो परेशानी हो जाएगी. और आप 50 बार 100 बार पूछिए सर क्लियर नहीं हो रहा है, क्लियर नहीं हो रहा है, please give another example, please give another example. I will be more than happy to explain, but if you confirm it, then you allow me for go forward. In between, if I ask you something, then is a problem. So please take care of this. Now we will meeting 10:25.
Excuse me, sir.
Yes, guys. So, are we ready for moving forward?
Sir, I have a doubt.
Huh?
I have one doubt, sir.
Doubt? Yes, go ahead with your doubt.
Sir, in the that tips data set, we have checked for outliers.
Yes,
So
tips.
outliers, like if we choose the different hues, then the outliers will change, right?
What, come again? What you are saying?
Sir, like when we say outliers, then we take one series, and in that, with respect to mean, we are drawing the viscous plot. But with respect to hue, it is changing.
Your voice is not audible here properly, or you are not able to. Yes. See, you are talking about outlier, and outlier will change. Or
Yes,
basically, what you want to say? You wanted to basically fix the outlier, right?
yes, yes,
Okay. So there are different possibilities. First, the easiest possibility basically you delete the outlier, right? But it is subject to how many percentage of the outlier are there. If there are millions of data points and there are very few, let's say 0.1%, 0.01%, something like that, then you can afford to delete all those observations, right? But if the data size is not too large, and if you delete those outliers, if you decide to delete, then let's say you supposed to lose 20% of the data, means 20% of the information. So that is not advisable at all. In that case, you have to impute. The term is used, impute the value over there. So that value may be mean, median, mode, whatever the way basically you want to deal. And within a mean also, there is trimmed mean also as well. Trimmed mean, guys, I have not explained to you, but somehow that term now came in our discussion. So trimmed mean basically is what? You have basically some population, let's say. So what you will do basically, 5% of population basically you will basically drop over here, 5% of population will drop over here, and then you calculate the mean. Okay, guys? Hello?
yes, sir.
So that might be also, that may be a case where we say you can impute with this mean, because essentially what you have done over here basically the outlier case always towards extreme, maybe left side, maybe a right side, maybe lower side or higher side. So you are cutting down by trimming this, right?
Yes,
So whatever mean comes, that can be used for the replacement, right? It is not like that only one strategy will work. You will
sir,
be.
but
Mhm.
we have to do that with this means every time we like the graph that is on the screen. So here we have plotted total bill versus day, and you is smoker. So we have created like 8 different series. So for that 8, we are counting this 5%, right? Every time it
Yes.
will.
So again, please mind it. This is I have given one example. It
Yes.
might work in one data set, might not work in another data set. I don't know whether it will work in this data set or not. It's again depend. Let's say, see, right now we are talking about this imputing only, but
Yes.
you are changing something, you are doing something, and after you have made some change, whether that change is bringing something to your own table, something improvement, if you can see on your model, all those related things basically you have to take care. Then only you will uh, come in a position. This is the best imputation for this particular outlier. Okay, it is not like that in isolation. Right now we will do. This is not the best way to doing it. Basically, some reference point should be there. By imputing this value, we got this much improvement in the performance. Then it's good imputation, right?
Right.
It is not like that in isolation. Right now you can impute. It's not possible. Okay.
Yes, sir.
Any other query, guys?
Thank you.
New query, guys? Any other query? Hello.
No, sir.
So we are good to go now.
Yes, sir.
Yes, sir, we can.
Okay. So we will. So guys, now I am going to start probability distribution. Okay. So idea here is this: I will be covering. I will not cover the whole probability distribution in one go. Means in one sequence. Okay. I will be covering one or two, and then I will take you to what naive based. Then there basically you will appreciate naive based that machine learning algorithm that is still pending. Because without having the knowledge of probability distribution, you can't do that. That's why I thought some distribution we will cover over here. Then we will go back there probability and we will finish that or the probability related stuff, right? Clear? So let me just open my OneNote. I'm opening OneNote for you guys. So let me just add a new page over here. And let's say today's date is, so I will be using today date 27th 22 April 22 April, and this is for this is basically we are starting probability distribution. Okay guys, so guys please let me know my mouse is visible. Guys, my
Yes, sir.
Yes, sir.
pointer is visible.
Yes, sir, it is.
So guys,
Yes.
I will not jump directly to the particular probability distribution. I will cover some examples, and then based upon those example that understanding, I will slowly move towards the probability distribution, right? Clear? So let's say one example basically is, let's say we are coining a toys, coin a toss. Yes, guys. So what are the possible guys? Possibility? Toss coining, two possibilities.
And
True and, oh sorry, tail and head, right? Guys.
yes, sir.
Yes, sir.
So let's say I'm representing tail with 0, head with 1. So I can say, let's say my random variable x. In this case, let's say discrete random variable, and it can take value 0 and 1. Two value either 0 or 1, right? Second, I'm saying, let's say, second example, let's say my random variable x is, will it rain tomorrow? Will it rain tomorrow. So it will again take two values. Either you will say yes or you will say no, right? So let's say for yes you are saying 1, for no you are saying 0. So can I say my random variable going to take two values, 0 and 1,
Yes.
right? Let me take another example. So let's say my random variable is x. Will a given customer purchase the product? Will a given customer purchase the product, right? So this is, so what are the possibility over here, guys? Again my random variable can say yes or
Purchase
no.
or not purchase.
Yes, yes, let's say 1 and no. So here basically x will take value 0 and 1. Okay, now one more thing, guys. Let me come to this example once again. In fact, if you see a pattern over there, in all the experiment, the random variable can take two values. Two outputs are possible, right? Okay, so actually the thing started in that way back in 17, 18, 19th century, the moment the time that people come up this idea, people observed the common behavior in some of the natural phenomena, right? Coining a toys, two possibilities. Will it rain tomorrow or not? Again, two possibilities. Okay, so in all such experiment, you will see a common pattern, right? Oh, this distribution spelling is mistake. No one has conveyed me, sir, it's a mistake. No one has distribution. Okay. So mathematicians and statisticians, they observed some experiment and they found that there is some common pattern. And not only this, if you talk about, if I talk about in terms of random variable that and all those basically taking two values. So this is comes under the PMF, guys, probability mass function, right,
Right, sir.
guys? And let's say the probability that my random variable x in this case is going to take value 0. If it is a fair coin, you will say 1 by 2. The probability that my random variable x is going to take value 1, the probability will be 1 by 2 if it is a fair coin, right?
Yes, sir.
Yes, sir.
Okay. Now in the same way, let's say here in this case might say my random variable going to take value 1. The possibility of rain, let's say you are saying 0.85. Then obviously the probability the rain will not happen, you will say 0.15, right? Clear? Because probability sum has to be 1. So there are two possibilities, two outcome, either 1 or 0. Isn't it, guys? In the same way, probability that my customer or random variable is going to take the value 1 means customer going to purchase. Let's say this is 0.05. Very low chances. Let's say this is the probability. So P is equal to X equal to 0 will be what? 0.95, guys? Guys?
Sir.
So generally, basically, in all the cases, if you consider, if you see the common pattern, there is one experiment that's supposed to have two outputs, right? And if you know the probability of corresponding to one output, automatically you can calculate the probability corresponding to other output. Am I right, guys?
Yes, sir.
Okay. In fact, in case of fair coin, let's say if it is a unfair coin, then in this case, let's say unfair coin basically means, let's say the probability of coming tail is, let's say 0.3 by 4, let's say 0.75, and probability obviously then in this case 1 going to be 1 by 4, because sum has to be 1, right? So in all such scenario, you will going to observe one common pattern. So this common pattern, basically they start saying this is some sort of distribution. They are following some common pattern. So the name they have given, if my random variable, going to see two values and one probability is given to us, we can calculate the other probability. So they have given the name, this type of phenomena, this is Bernoulli distribution, right? This is Bernoulli distribution. So my random variable going to be a Bernoulli distribution. Bernoulli distribution. If there are two outcomes, right? And second, the probability of one event, let's say any event, if it is given P, then obviously the probability that another event is obviously going to be a 1 minus P. Generally it is written as Q in textbook, right guys?
Yes, sir.
Right, sir.
Okay, so this random variable is representing one phenomena. Okay, and now, so in every distribution you are going to encounter one thing, that is parameter of the distribution. Parameter of the distribution. So guys, in this case, in case of Bernoulli distribution, parameter always going to be probability. Okay, and generally basically in textbook you will see a concept of success and failure. And again you can define it like this as it, right? 1 and 0. Idea is clear. So random variable can take two values, and if you know the probability of success, that is P, then obviously you can calculate the probability of failure also. So in other words, we already know the random variable if having the two outputs, and somehow if you came to know the probability of one event, or you can say success is given to us, then we can calculate the other things of this distribution. Guys,
Yes,
guys,
Sir.
clear? So now let me say in Hindi. देखिए सराउंडिंग अस अपनी सराउंडिंग बहुत सारी चीजें आपका एक कॉमन पैटर्न सा होता है, फॉलो होता है. तो मैथमेटिशियन स्टैटिस्टिशियंस ने ऑब्जर्व किया कि कॉमन पैटर्न क्या है, तो उन्होंने देखा कि ये रैंडम वेरिएबल इस तरह का है, इसके दो आउटपुट पॉसिबल हो सकते हैं, एंड इफ वी नो द प्रोबेबिलिटी ऑफ वन आउटपुट देन ऑटोमेटिकली द प्रोबेबिलिटी ऑफ अदर आउटकम कैन बी कैलकुलेटेड, बहुत इजी कैलकुलेट कर सकते हैं. तो आपका इन्होंने इस तरह के पैटर्न को, फिनोमेनन को नाम दिया बर्नौली डिस्ट्रीब्यूशन. तो बर्नौली डिस्ट्रीब्यूशन का पैरामीटर क्या होता है? पी. और बर्नौली डिस्ट्रीब्यूशन से अपने आप ऑटोमेटिकली आपको पता पड़ जाएगा कि इसके दो आउटकम होने वाले हैं, राइट? सक्सेस एंड फेलियर. तो ये बर्नौली के नाम से ही पता पड़ जाएगा आपको कि अब इसके दो आउटकम होते हैं, सक्सेस और फेलियर. और दूसरा आपको क्या चाहिए? केवल एक पैरामीटर चाहिए इसका, वो चाहिए पी. राइट गाइस, आइडिया इज क्लियर?
Yes, sir.
Okay, now see, since this distribution is a discrete in nature, why we are saying discrete in nature? Because it can take two value. This random variable can take two values, 0 and 1, right? Clear? So that's why we will define PMF. We will not talk about PDF over here, we will define PMF over here. So see over here. So guys, can I say this? Can we draw the PMF like this? Let's say, so let's say the in case of, let's say if you are saying my random variable x is following the Bernoulli distribution with p is the probability of success. So generally we used to say the this can take two values, 0 and 1. So we used to say this is probability is given to us when x equal to 1, this is given p, then automatically the 1 minus p will be the probability that x is going to take a value 0. So this is given, right? Now if we draw PMF for this, guys, so what is PMF? PMF basically is giving the probability. Can I say this, guys? Guys, we all are agree with this? PMF is
Yes,
nothing
sir.
but giving the probability, right? Mapping function की तरह काम करता है, मैंने बताया आपका. तो देखिए, my random variable can take value 0, my random variable can take the value 1. Two possibilities are there, right? If it is going to take the value 0, then the probability will be 1 minus p, guys. What do you say? If the probability of my random variable x is equal to 1 is p, then the probability that random variable going to take value 0 will be 1 minus p, guys. All are
Yes, sir.
agree? All are agree, na?
Yes, sir.
Okay. Now talk about its CDF. CDF, ध्यान रखिएगा, probability x less than or equal to a, up to a, right? So this is nothing but basically, if you talk about in terms of integration, you will say minus infinity to a, right guys? And here in terms of summation, basically you will say all possible value up to a, including a, right guys? Bolo beta.
Yes, sir.
Yes, sir.
Yes, sir.
So now let's say my random variable basically 0 and let's say 1. This is, so I'm talking about basically CDF now. So when I'm saying probability that my random variable capital X going to take value less than or equal to 0, What is the probability? We have already discussed 1 minus p, right? Guys,
Yes.
let me basically just, oh, sorry, use a point only. I will be using point only. 1 minus p, and this is a point, let's say. This is 1 minus p. Okay? Why I'm removing and using point? There is an intention for this. Now, what is the probability, guys, when x is less than or equal to 1? This is nothing but basically you will say the probability that random variable is going to take value 1 plus probability my random variable is going to take the value 0, because there any value less than 1, all will be part of this, because this is a CDF, right, guys?
Yes, sir.
So this is going to be how much? 1. So this will be 1 only, right? Right, guys?
Yes, sir.
Because sum is supposed to 1. So now if I ask you, what is the probability that my random variable x going to take value less than or equal to 0.5? What is the probability, guys, in this case? Guys, theoretically, if I am asking this question, the probability value is nothing but basically this is equal to this only, right?
Yes,
राइट
sir.
ना? तो
Yes,
देखिए
sir.
यहां से आप क्या कहते हैं स्टेप फंक्शन हो जाएगा. देखिए यहां से एक लाइन ड्रॉ करेंगे, दैट इज नॉट एक्जैक्टली x इक्वल टू 1 बट टेंड्स टू x इक्वल टू 1, दिस पॉइंट, राइट? In the
Right,
same
sir.
way, when if I ask you probability that x random variable going to take the value 2 or something like that, so it will be once again going to be equal to the random variable going to value x equal greater or equal to 1. So this is 1 only, right? Clear?
Right, sir.
So in fact this line you can extend up to infinity also. Clear now?
Clear, sir.
Yes, sir.
This is, so this PMF we have defined it, we have defined the CDF of this random variable also, right? So mind it, my random variable x is following the Bernoulli distribution. So what is the parameter of Bernoulli distribution? You should be knowing only one probability of success. Then automatically you can calculate everything. Bernoulli name itself coming with the flavor that this variable going to have a 2 output, right? Clear? Clear, guys?
It is applicable for both, na? PMF and CDF.
Huh?
It is applicable for both PMF and CDF, Bernoulli's distribution.
Sir, please revisit the concept. I conveyed you 2 types of random variable, discrete and
Right,
continuous.
discrete and continuous.
Okay.
Right.
In case of
Discrete,
discrete, PMF
PMF
and
and
CDF both
CDF.
are there.
Right.
In case of continuous, PDF and CDF are there. So
Yes, sir.
whatever distribution we are covering, sometime you will be covering discrete random variable based distribution. Sometime you will be covering a distribution that is continuous random variable based, right? So in case of
Yes,
continuous,
sir.
then you will be talking about PDF and CDF. In this case, PMF and CDF. So you tell,
Yes.
this is clear now? समझ में आ रहा है ना?
Yes, sir. Got it.
Okay. Now let me take you further. अब मेरे को ये बताओ बेटा, अब what is your name?
Yes.
Ayas. Okay. You tell what is the mean of a random variable that we have defined generally. What is the mean of the random variable, guys? This is nothing but basically expectation, right?
Yes.
Yes.
So what is the formula of expectation? This is a discrete in nature, mind it. So please convey accordingly. This is summation, can I say summation of all possible value of x that my random variable can take, and this is the value, and this is the probability that it will take this value, right?
Yes, sir.
Yes.
So my random variable can take 2 value over here. So I can write like this: 0 into probability that my random variable is going to take value 0. This is the probability, plus my random variable can take value 1, and this will be the probability P1, right? Clear? Bolo bhai.
Yes.
Yes, sir.
This will be 0 and this will be basically 1 into. We have already said that basically the parameter should be knowing. If we are saying x is a Bernoulli distribution variable, then p must be knowing to us, p. So this p is known to us, so this is going to p, because I already told you this probability is given for success. Generally we used to take success, right? So in this case it's going to p, right, guys? Idea is clear, guys? Idea.
So
Yes, sir.
Now what is the variance in terms of expectation, guys? We have discussed this also. Can you convey what was that? Guys,
Px minus mu square.
E of x square minus
E x square minus E of x
E of x.
Whole square.
whole square, right? So now E of x square basically is what? This is some sort of function. So if you recall, so this is, we can write like this, x square, sorry, x will take two value. So basically the zero value square into p0 plus 1 square into p1 minus, this is expected value already calculated, this is p square, guys, right now.
Yes.
If you recall, we started with this x into px. This is expected value for the mean for basically a random variable x, going to take the value, all possible value of x. In the same way, if you recall, I told you g of x is nothing but basically all possible value of x. We will say g of x, then p of x, right, guys? If you recall, same thing I applied over here. All possible value of x, so 0 square, then p0, 1 square, p1, right? Clear, guys?
Yes, sir.
Yes, sir.
So this is going to how much? This will be 0. So this will be p minus p square. Am I right? And this is nothing but basically, if you take p common, 1 minus p, and this is written as pq. If p is the probability that my random variable going to take the value 1, and let's say this is representing success, then the failure will be represented by 0, and this value will be 1 minus p. Right, guys? This is probability for 1,
Yes, sir.
probability for 0, and this is generally written as with q. So this way I have written q. So this derivation is clear. How we basically calculated mean value, how we calculated the variance value. This derivation is clear.
Yes, sir.
Any confusion, guys? Any confusion? अच्छा मुझे बताइए. Now, how we are going to calculate the value of p? How we are going to estimate the value of p in runtime, general scenario, live scenario, when data set is given to you? How you are going to calculate it? So intuitively, can I say p probability generally is defined as the proportion? Probability means proportion only, guys. Can I say this, guys?
Yes, sir.
So let me explain this concept by taking one example, how we can estimate the probability value p, how we can calculate the probability value p, that basically we will estimate now. So let me summarize whatever till we have done it. We are saying basically my random variable x is a Bernoulli distributed random variable with p is the probability given, then its mean going to be a p, and its variance going to be a p into q, that is p into 1 minus p. All are agree with this, guys?
Yes, sir.
Yes, sir.
Now let's say a purchasing of, let's say purchase of, let's say I am taking example of e-commerce, purchase of product. Okay, there are millions of that customer on Amazon website. I'm taking example of e-commerce company, e-commerce website. Okay, and there is one product, and there are million of customers are there. So let's say C1 might not purchase this, C2 might not purchase this, C3 might not purchase this, C4 might purchase this, right? Then C5, C6, so and so on. So purchase will be represented by 1, and not going to purchase will be represented by 0. Let's say this is the theme, right? So how likely a person going to be purchase this product, that you can estimate by like this. So this will be a estimated probability. This is, you can say, uh, total number of customer corresponding, you got the 1, means they have got purchased it. So I am writing total number of favorable cases where you will get the 1 upon total numbers n0 plus n1. All are agree with this example, guys?
Yes,
sir.
Yes, sir.
So, yes, sir. So with this example, now the random variable is Bernoulli distributed. Why you are saying basically, sorry, not Bernoulli, sorry, just a minute. Actually, next coming up is binomial. Bernoulli and binomial both are tongue twisted. So please be careful. Being an experienced person, still I confuse sometimes. So this is I am talking about the Bernoulli, not binomial. Bernoulli ka extension है binomial, right? So in case of Bernoulli, what is the pattern? Pattern is basically the customer will purchase or not purchase. So my random variable will take two value, either 0 or 1, right? This is pattern clearly visible to us in this example. And if it is this given to us, we can estimate the value of P, right? If we estimate the value of P, then obviously we can answer the query on an average. What do you think? How many customer will purchase this product? Then you will say this mean is P. I have collected a sample, and based upon sample, whatever P I estimated, that will be the mean, right? Clear? Clear, guys?
Yes, sir.
Yes, sir.
In the same way, what is the variance? You can say, if I calculated P, then I can calculate the variance by P into Q. So I will substitute the value of P and then 1 minus P multiplied by 1 minus P, right? Idea is clear?
Yes,
Idea
sir.
is clear?
Yes, sir.
Okay. Now, guys, time is 11. After this, it's up to us whether you want to do the coding for this or you want to go with the Bernoulli also. Sorry, binomial also. Then we will do the coding. That we will take a call at 11:30, right? So, guys,
Yes, sir.
this Bernoulli distribution is clear to all of you.
Yes, sir. Yes, sir.
Yeah.
और डिस्ट्रीब्यूशन का लेवल में क्या मतलब होगा कि एक जनरल पैटर्न है जो बहुत सारे फिनोमिना में कॉमन मिला। वो पैटर्न क्या है कि रैंडम वेरिएबल इस तरह के केसेस में इट विल टेक टू वैल्यूज। इफ एनी रैंडम वेरिएबल स्टार्ट टेकिंग टू वैल्यूज then it's a case of Bernoulli distribution. Bernoulli distribution, and the probability will be P. Okay.
Yes, sir.
You will
Sir?
realize very soon why I am again and again basically using the binomial. So please take care of this. Now I will
Sir?
also take care. Yes.
Sir, there is a confusion between Bernoulli's and binomial distribution. So can
There is
you
no
tell that?
confusion. There is no confusion. Confusion basically because I am trying to speak in flow. So that's why tongue twisted. Otherwise, there is no confusion.
So, sir,
Bernoulli,
can you tell the
Bernoulli,
difference between Bernoulli and binomial by giving some example?
we will cover this after 11:30, right?
Yeah, okay, sir.
Okay, and
Okay,
very easy to distinguish, right?
okay.
Okay.